In this video, we'll see how to define functions and how do you import functions from different files, how do you create definitions and so on. Right, so let's take the following example where I want to, let's say, compute the area of a circle. Right, so I want to write a function which, when given the input, given the radius as input, it outputs the area of the circle with the specified radius. The way you define a function is the following, right? Def function name, so let's say compute circle area, and then you specify what the inputs are going to be. So let's say radius, and start with a colon, and remember that an indented sequence of lines of codes corresponds to a block. So all the contents of this particular function have to be indented using, say, one tab. Okay, so what is the radius? Let's what is the area? So let's say area equal to pi. So let's do it approximately 3.1416 times uh, radius square. Right, so this gives the area, and the function has to return the area. So say return area. Okay, now I want to compute the area. Suppose I can say print area equal to compute circle area of, let's say, 3, right? So this gives me print area of the circle of radius say 3 is equal to area. Alright, so this gives me the area of a circle of radius 3 is equal to 28.2744. Now the nice feature about Python compared to, say, C or C++ is that you can return multiple things. So suppose I want to return both the radius and the area for whatever reason, right? I can say return radius comma area, and now, right, so this actually returns a tuple. When I say return radius comma area, it returns a tuple where the first element of the tuple is going to be radius and the second element of the tuple is going to be area. If I run this, I'm probably going to get an error, but yeah, so it's this. Yeah, so it's a tuple 3 comma 28 to 28.2744. So really, to get it correctly, I should get radius comma area is equal to compute circle area of 3, and that will give me the following. Right, so this is how you would define a function. Again, it's fairly flexible. You would have seen how to define functions in C or C++ or MATLAB, and everything is quite similar. Now, in many cases, when you're not using Jupyter Notebooks, when you have a much larger project, you want to define certain functions, you want to define certain constants, and include it in a particular file. So for example, in C, you would define a header file where the function definitions are present, where constant definitions are present, and separate library files or other C files where you define certain functions that you want to reuse in different parts of your project. Now you can do the same in Python as well. So everything is a .py file, so I can create a new file called, let's say, include file.py, wherein I am going to call this particular function. Right, so let me take this Let me perhaps take a different example. So I want to go to include file.py. Let me perhaps define something else. So I'll say that pi is equal to 3.1416, and I'm going to define a function. So def, let's say I want to compute the volume of a sphere of a certain radius. Compute sphere volume of radius. That's going to be the input. I can specify multiple inputs if required. And I'm going to say that volume is equal to 4 by 3 into pi into radius cubed. I will return volume. And I'll save this particular file. All right. Now if I want to compute the volume, now I want to basically use this function in another file. Right. So in this case, I have to import this file, the include file, in the file where I'm going to call this function. So the way to do it is the following. So I'll say import include file, and let's say radius equal to 2. I want to print, let's say, compute volume. Volume is equal to, so I want to call that particular function. So I'll have to say include file dot the function name, which is compute sphere volume. Compute sphere volume of radius. We print volume of sphere of radius. Radius is equal to volume. All right. So this tells me that the volume of the sphere of radius is equal to volume. Now let's say I just want to print pi. I want to know what value of pi was used. So right now I can't get pi. But what I can instead do is I can print include file dot pi. So this is a constant which is defined in that particular file, and this gives me 3.1416. Now there are different ways of importing a particular file. You can see that this is quite cumbersome. Right, I'm saying import include file, and every time I want to call this particular function, I have to say volume equal to include file dot compute sphere volume of radius, which can be a little it can look a little clunky. What I instead do is I can rename this particular thing. So instead of saying import include file, I can say import include file as say if. Sorry, in infl. Right, and then you can say volume equal to infl dot compute sphere volume of radius, and I can say infl of pi. Okay, so these are two different ways of including this particular file in your including that particular file or a library in your given executable file. All right. You can also, there's another way of including. You can just say import include file as star, in which case I don't need to include any of this. Oops. From include file import star. So if I don't want to say include file dot function name, or if I don't want to say whatever infl dot compute sphere volume, I can just say from include file import star and then just use the file name as it is. However, it's a good idea to be careful, because suppose you're importing multiple files, there could be certain functions or certain constants which have the same name in those include files. It's always clear, it's good to know which functions have been imported from which particular module, right? So this is certainly a valid way to do things, but it's sometimes nice to say to just use import include file as something, say infl. All right, just to be clear that you know where these particular functions are defined when you go through the code later on. All right, but this from include file import star, instead of this, I can also say from include file import, let's say py. Okay, in which case, okay, so this was not a good idea. Let me clear the outputs of all cells. I will restart the kernel. So right now it's forgotten everything. Now I'm going to get an error because compute sphere volume is not defined. So from a given module, the module in this case is include file.py, I can import only certain functions or certain variables. Right, maybe I don't want to include everything. In my particular project, I only want to include certain functions. So in this case, this is a good way to do it. So I can So if I just want to import the definition of py, I can do so by saying from include file import py. If I only want to include this particular function, then I can say from include file import compute sphere volume, and then the function would run perfectly. All right. So this is a way to sort of include modules. Basically, you write functions and definitions in a separate file, and then you include parts of that in your program. Right? But you can also use the same syntax or the same approach to also include files from other libraries. So recall that in a previous video we had installed certain libraries. So for example, suppose I've installed these libraries numpy and matplotlib. So if I want to say use functions from the library numpy or from the library matplotlib, then I can add those by saying import numpy as np, import matplotlib. So what I'm going to do is from the matplotlib library, I'm going to use a sub library called pyplot as plt. Right, because these are the only modules that I require in my particular program. So let's say I want to plot a function of x square, right? I can do so by importing these two libraries. We'll see more of NumPy and Matplotlib in a future video. But just to see how you would include libraries in your particular file, you'd say import NumPy as np, import matplotlib.pyplot as plt. Then just like a range, I would define something. There's a similar function called arange in NumPy, which does the following. So x equal to np dot arange, the initial value, let's say I want to plot from -1 to 1, so -1, comma 1, and I can define the steps, right? Just like arange, I have an initial value, a final value, and the increment to step through. Unlike range, where you can only increment by integer amounts, in this case I can increment by any floating point. So for example 0.01, and I can define f to be x square. So unlike operations on arrays, operations on these numpy arrays work a little differently. So this is component-wise squaring, and I will plot x comma f plot this. So this gives me a nice plot of f of x equal to x squared. Okay, so this is how you can define functions. You can include functions in your code. You can call functions. You can write separate modules containing functions and variables, and you can include those in your code. Call those functions, and also call functions from other libraries, third-party libraries, and include those in your code.